review for inequalities. All right, I hope this helps you. So we're going to just get started. So here you got to always solve for x. So in this case, the step to solve for x would just be to divide by 8. So I'm going to divide by 8 on both sides. So when I do that here, since I just divided by a positive, I don't need to do anything with flipping the sign or anything like that. So I see I get x is less than 3. So I'm going to put an open circle over 3. Okay, it's not closed because this is not an or equal to, and now the arrow is going to go to the left because it's less than. So now, let's look at all our possible solutions. Is 1 a possible solution? Well, where's 1 on the number line? It's in the solution set, so we check it. Where's 13? It's way over here to the right, so that's not an answer. What about 4? No, that's not in our number line where the arrow is going. What about -4? Sure, -4 is right here. What about 3? So 3 is not a solution here because this does not have an or equal to. So since it's an open circle, it is not a possible solution. All right, let's try it here. So here on screen 3, we still need to solve for x. Okay, notice again, just one variable here. So we're just solving the inequality. But now we've got 2 steps to do. So the first step should be to subtract 2 from both sides. And now we are going to subtract the 2 we get here. Now we're going to multiply by -3. So we multiply by -3 on both sides. Once that happens, we get x is less than 1 times -3 is -3. So now we get here. Okay, open circle because there's no or equal to at -3. So that should be somewhere kind of in here. It doesn't have to be perfect, but you should kind of show you understand it's a little bit less than 0, right? Okay, at -3, now this is x is less than, so arrow to the left. Okay, now let's look at our possible solutions. -12, yeah, that's like in here, right? So that should be a possible solution. Where's 21.3? That's way up here. No. -15, yep, that's in the solution set. 0, nope. That is not in the solution set. It's too far to the right. What about 14? Now that's way over here. So it's just these 2 answers. Okay. Number 4. So now we still need to solve here. There's only one variable. I always suggest getting the variable on the left-hand side. It's the way that students are used to seeing it. So I would subtract 2n to start here. So I'm going to go -2n on both sides. So then 4n minus 2n is 2n minus 6 greater than 1. I need to cancel that -6, so I'm going to do +6 to both sides. When I do that, I get 2n greater than 7. I'm going to divide by 2 on both sides. And then I always like to change it to a decimal. So 7 divided by 2, 3.5. If you don't feel like you would know how to do whatever the division is in your head, keep in mind there's a calculator right here. You can always type that in. Okay, so 3.5. What's that between? Between 3 and 4, right? So your circle should go between 3 and 4. Since there's no line underneath, it's not a closed circle. It should be open, so not filled in. It's greater than. So we're going to draw the arrow to the right. And now let's check for the possible solution. So 4, yes, 4 is on the number line that's in the part of the solution set. -6, now that's like way down here. That doesn't work. -7, where's that? Yes, that's down here. That works. 12, nope. That would be way up where the number line would continue. So that, I'm sorry. So yes, so 12 would be a solution. It would be on the line because remember this arrow means it keeps going to the right forever. What about 2? Nope, 2 is on this side. It's not part of the number line for the solution set. So it'd be these, oops, not -7. Sorry, I put that by accident. -7 would not be part of the solution set. So again, it's just everything that's above or greater than 3.5. So these are the only 2 that are greater than 3.5. All right, one last scenario to solve here in this way. So now we see this problem. So right away when I see that -4 on the outside, I'm going to think, hey, I need to multiply, aka in this case, distribute. So I'm going to distribute the -4 to both of these. So -4 times p is -4p. -4 times -6 is +24 is less than or equal to 20. Okay, so now what? I need to solve for p. So my next step should be to subtract 24 from both sides. So I'm going to do that. Once I do that, I get -4p less than or equal to -4. 20 minus 4, 20 minus 24, -4. Again, use the calculator if needed. All right, now I got to divide by -4, and then you got to remember here, I divided by a negative. The sign of the inequality needs to flip. So I'm going to do greater than or equal to. -4 divided by -4 is +1. Okay, so I'm going to put a circle above -1, but it's an or equal to, so I need to fill it in. And what that means here, specifically, is that 1 is a solution because it's a closed circle. Now we read it. It says P is greater than, so we're going to do an arrow to the right. So everything that's above 1 is a solution. So 4.5, yep, that's up here, that's a solution. -2, no. -14, definitely not. 0, no. So there's our solutions. Okay, so now let's look at it when we're graphing for an inequality on a coordinate plane. So now we have an x and a y variable. So when we see the shading here, if it's in the shaded region, it's a solution. If it's in the unshaded region, it is not a solution. If it is on the line and the line is solid, it's a solution. If the line is dotted or dashed, it is not a solution. So here we go, 0, 2. Where is that point? 0, 2. That is right on the line. Since that's a solid line, that is a solution. -3, -5. So -3, left 3, down 5. That definitely is a solution. It is in the shaded region. 3, 7. So right 3, up 7. That is in the unshaded region. That is not a solution. -4, 2. So -4, 2. Yeah, that is in the shaded region. That is a solution. 8, 0. Right 8, up, down, none. That is not a solution. It's not in the shaded region. So again, in the shaded region, solution. Non-shaded region, not a solution. If it's on the line and the line is solid, it's a solution. If the line is dotted, it is not a solution. Okay, so now let's go to where instead of having this given to us, we have to make this. So here we see y is less than 1/2 x plus 1. So since this is already solved for y, we should know the slope. It's this number right here in front of x. So it's going to be 1/2, and we should know the y-intercept, which is always going to be this number on the back end, which is 1. Keep in mind, if there's no number written for the y-intercept, it's like having it be a 0. And if there's no coefficient in front of x, but you still see an x, it's like having this slope be a 1. All right, so here we go. So the y-intercept's a 1. So I'm going to put a 1 right there. And now the slope's 1/2. So I'm going to go up 1, right 2. Up 1, right 2. Up 1, right 2. Now I can do this a whole bunch of times. I like to do it a few times, but you don't have to do it more than twice technically. I like to do it a few times here though when I'm drawing it, and we care about it being specific. So now since this is just a less than, we want that dashed or dotted line. So it should be pretty clear that that line's broken apart. Now where do we shade? Well, that's a less than, so we're going to shade everywhere below that dotted line. So everywhere I'm shading right now, those would all be solutions. So now when it says, are these solutions? Well, let's just check them. 4, -1. So left 4, my bad. 4, right 4, down 1. Let me use a different color. Right 4, down 1. That's in the shaded region. That is clearly a solution. 6, 1. Right 6, up 1. That's in the shaded region. That's a solution. -3, -4. So left 3, down 4. That is a shaded. That's in the shaded region. -2, 3. So left 2, up 3. That is not in the shaded region. So that would not be a solution. In this case, if it was on the dotted line, it would not be a solution because that line is not solid, so it would not make this true, okay, because we don't have the or equal to sign. Now let's do one that's similar, but now we have to actually solve for y. So we see -6x plus 3y is greater than or equal to 9. Okay, I want to get the y alone here. So to do that, I need to cancel the -6x with +6x. So I'm going to add 6x to both sides. I'm going to get my 3y. Then these are obviously not like terms. I want to put the part with the x first. So 6x plus 9. Now I need to cancel the 3. So I'm going to divide by 3 everywhere. Y is less than or equal to 6x divided by 3 is 2x. 9 divided by 3 is 3. So now we've solved for it. So what's my slope? Well, what's the number in front of x? It's a 2. What's my y-intercept? Well, what's this number back here? It's a 3. So now we need to graph it. We need to figure out what kind of line we have. We need to then figure out where we shade it. So the y-intercept's at 3, so we go to 3. The slope is 2. Remember, if you want to, you could write this as like 2 over 1 to help you graph it. So we're going to go up 2, right 1, up 2, right 1, up 2, right 1. You know, that's kind of the deal. Since this has a line under it, it is going to be an or equal to, boom. And now we're going to toss some arrows on the end of this. Alright. Alright, so now that we put some arrows on the end of that, now we got to figure out where to shade. It's a greater than, so we're going to shade everywhere above the line. So anything in that region I just shaded will be a solution, and since this is a solid line, anything on the line would be a solution as well. And lastly, let's look at it with the practical problem. So you're asked to save money and find new headphones. The headphones cost $100. You already have $40. You're mowing lawns to make money. You earn $15 for each lawn you mow. We need to set up this inequality and solve it. I'm just going to show it all right here, though. So first off, let's figure out what we have. We have 40 bucks, so I'm going to write my 40 down. That's what I have right now. And then I'm making money, so I'm going to add money. How much? 15 for every lawn that I mow. I'm going to just put X. You could put L for number of lawns. We want to have $100 to buy these headphones, so we need at least that amount, so or equal. Now, is it okay if we have more than $100? Of course. So we're going to put a greater than or equal to, because we want this amount, but we want that to be that or more, so we need a greater than or equal to. And now you just solve your inequality. So I'm going to subtract the 40, right, which if you think about this in the real life scenario, like you're trying to save for something that costs $100, you already have $40. So that means how much do you actually need to get? You need to get 60, right? So then that's what that looks like. And now, well, we're trying to get 60. We make 15 for every lawn we mow. So let's divide by 15 to figure out how many lawns we need to mow. 60 divided by 15. Again, use the calculator here if you need to. 60 divided by 15 is going to give us 4. So you're going to get greater than or equal to 4. What does that mean? It means we'd have to mow 4 or more lawns to get the $100 for the headphones, right? This means a minimum. So we'd have to mow a minimum of 4 lawns to get the headphones. All right. Hope all this helps. Please review these, and let's do great on the test.